Grade 9 Maths, Chapter Number System. So we'll understand the chapter thoroughly and then we will dive into different type problems. So first we need to understand what is numbers. So there are counting numbers like 1, 2, 3, 4, 5, etc. So these are called natural numbers. Now include 0 in natural numbers. So this becomes now whole numbers. So whole numbers are those numbers that is 0 and the natural numbers. Now let us include the negative of natural numbers. So that is -1, -2, -3 like this. So these are called the integers. So integers are the whole numbers plus the negative part of it. Now 5 by 9, -3 by 1, 4 by 3, 1 by 5. What are these type of numbers? See, if you check the numerator, these are all integer. And in denominator, these are all non-zero integer. So the ratio of the integers is called the rational numbers. So rational number, as a definition, we can say that if p is any integer and q any non-zero integer, then p by q is a rational number. Now let us take some examples like 9 by 4, which gives us as a decimal as 2.25, 11.3, 11 by 3, which we divide, we will get 3.666 and this will continue. So 9 by 4, as we can see, 2.25. So after that, there is no remainder, so it is terminating. 3.666 and it will continue. So that means it is non-terminating and recurring. Recurring means here we can see that digit 6 is repeating itself multiple times. So that's why it is repeating. So we can also alternately call it recurring. Decimal form of rational number is either terminating or non-terminating and recurring. So 3.666 dot 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 can also be expressed as 3.6 bar. So whenever the particular digit or the number of digits will be repeating, we will put the bar on top of it. Now let us take a look at another number, 4.914 dot dot dot. So here 914 is repeating. So that's why we have to put the bar on top of 914. Now out of these numbers, let us identify the rational numbers. 0.048 bar. So we can clearly see that there is a bar on top of 8. So that means 8 is repeating over here. So we can say that it is a non-terminating recurring. So we know that earlier, as per the definition, that decimal numbers feature terminating or non-terminating recurring are called rational numbers. So we can clearly say that this is a rational number. Now let us take a look at the next number, 4.914 bar. So 914 is repeating over here. So this is a non-terminating recurring number. So this is also a rational number. Now 2.066. There is no repetition over here and it got terminated. So this is a terminating decimal number. So this is also a rational number. Now next number, let us take a look. 0.01225478825 dot dot dot. Here, if you take a look, there is no particular digit is repeating. So, and also the number is not terminating, right? So, this is called the non terminating, non recurring number. So, this is not a rational number because whenever a particular decimal number is non terminating and non recurring, that is not a rational number. Now 3.14592653 dot dot dot. Here also we can see that it is non terminating and non recurring. So this is also not a rational number. 2.613530298864 dot dot dot. This is also non terminating and non recurring. So it is also not a rational number. Now 1.903574155569 dot dot dot. This is also non terminating and non recurring. So it cannot be a rational number. Now 270.253 bar. So here we can clearly see that 253 is repeating. So this is a non-terminating recurring number. So that's why it is a rational. Now earlier we have seen that there are some numbers which are non-terminating and non-recurring. So what type of numbers are they? These decimal numbers are non-terminating and non-recurring as I explained already. So these set of numbers are called irrational numbers. So irrational numbers are those are non-terminating and non-recurring. Let's find the square root of numbers that are not perfect squares, like root 2, root 3, root 5, root 6. If we check the value of root 2, it is coming around 1.414213562373 dot dot dot, which is non-terminating and non-recurring. Like root 3 is 1.732050807568 dot dot dot. This is also non-terminating and non-recurring. Now root 5 that gives you 2.23606797997499 dot dot dot. This is also non-terminating and non-recurring number. 2.449489742783 dot dot. This is the decimal form of root 6. So these are all we can see that non-terminating and non-recurring number. So that's why we can say that the square roots of numbers that are not perfect squares are irrational numbers. Now you already know that natural numbers are 1, 2, 3, 4, the counting numbers. Whole numbers are 0, 1, 2, 3, 4, etc. Integers are negative part and the 0 and 1, 2, 3, 4, etc. So these set of numbers belongs to the rational numbers. So rational number we can also say that integer divided by any non-zero integer or terminating, and that should be terminating or non-terminating recurring. That will be the rational number. Now irrational number is non-terminating, non-recurring numbers. So if we take this combined, there comes the real numbers. So real numbers can be divided into two parts, that is rational number and irrational number. So rational numbers are those numbers which can be written in p by q form, or that has to be terminating or non-terminating recurring number, and irrational number are those numbers which are non-terminating, non-recurring number. Now let us take an example. Now 8 divided by 2. So we know that it gives you, here 8 is the dividend, 2 is the divisor, and 4 is the quotient and 0 is the remainder. So we know already this dividend equal to divisor into quotient plus remainder. So 8 can be expressed as 8 equal to 2 into 4 plus 0. Now another example, 15 divided by 2. So 15 equal to 2 into 7 plus 1. So if we generalize this, we can write it A, which is the dividend, equal to B, which is the divisor, into Q, that is quotient, plus remainder R. So for any two given positive integers, A and B, A equal to BQ plus R. So in this case, what we observe that R value can be 0 or 1. So 0 should be less than or equal to R, and that should be less than B. So that means that remainder will be the value from 0, which should be less than from 0 to less than B. That means less than the divisor. So in this case, since the B value is 2, so that's why remainder can be 0 and 1 only. So this is called the Euclid's division algorithm. So if we again reframe it, we can say the Euclid's division algorithm as for two given positive integers a and b, there exist unique integers q and r satisfying a equal to bq plus r, where 0 less than equal to r less than b. Now let us solve some problem. Is 0 a rational number? Can you write it in the form where p and q are p by q, that are integers, and q not equal to 0? Yes, 0 is a rational number. So 0 can be written in any of the following ways, like 0 by 1, 0 by minus 2, 0 by 3, 0 by minus 7, etc. Thus 0 can be written as p by q, where p equal to 0 and q is any non-zero integer. Hence 0 is a rational number. Note: to find n rational numbers between any two rational numbers, we will multiply both the numbers by n plus 1 by n plus 1. So now let us take a look. Find 6 rational numbers between 3 and 4. So here we need to find out 6 rational numbers between these two numbers. Since we require 6 rational numbers between 3 and 3 and 4, so we will write, first we are going to apply, to find 6 rational numbers between any two rational number, we have to multiply both the numbers by n plus 1, that is 6 plus 1 by 6 plus 1, that is 7 by 7. So 3 can be written as 3 by 1. Now we will multiply this 3 by 1 with 7 by 7, which comes 21 by 7, and 4 can be written as 4 by 1 equal to 4 by 1 into 7 by 7, which is 28 by 7. Now we have to find the numbers, rational numbers between 21 and 28. So those are 23, 22, 23, 24, 25, 26, 27. So we can write like this. So these are the 6 rational numbers between 3 and 4. So we have to exclude the 21 by 7 and 28 by 7. since we have to find the in between numbers, and we can write the in between numbers of 3 and 4. Now another question. Find 5 rational numbers between 3 by 5 and 4 by 5. So here we need to find out 5 rational numbers. So to find 5 rational numbers between any two rational numbers, we need to multiply both the numbers by n plus 1 by n plus 1, that is 5 plus 1 by 5 plus 1, that is 6 by 6. So 3 by 5 equal to 3 by 5 into 6 by 6 equal to 18 by 30, and 4 by 5 equal to 24 by 30. Now we need to find the rational numbers between 18 to 24. Now we have to exclude those 18 by 30 and 24 by 30. We have to take the orange set. So this is the final answer. Now another problem. State whether the following statements are true or false. Give reasons for your answers. Every natural number is a whole number. Yes, true. Every natural number lies in the collection of whole numbers. So we know that natural numbers are 0, 1, natural numbers are 1, 2, 3, 4, 5, etc. And whole numbers are 0, 1, 2, 3, 4, 5. So that means natural number belongs to whole numbers. That's why every natural number is a whole number. But one thing you need to keep it in mind, that every whole number is not a natural numbers, because 0 is not a natural number, but it is a whole number. Every integer is a whole number. So we know that integers are the negative part, then 0, 1, 2, 3, 4, etc. And whole numbers are 0, 1, 2, 3, 4, etc. But here we can see that minus 3, minus 2, minus 1, these are not whole numbers. So that's why it is false, because minus 3, minus 2, minus 1, these are not the whole numbers. Every rational number is a whole number. Whole numbers are 0, 1, 2, 3, 4, etc. And these can also be written as 0 by 1, 1 by 1, 2 by 1, 3 by 1, etc. So which are rational numbers? But if we take a look, 1 by 2, 3 by 4, 5 by 2, 7 by 2, these are not whole numbers. So that's why all the rational numbers are not the whole numbers. So this is a false statement. Now another problem. State whether the following statements are true or false. Justify your answers. Every irrational number is a real number. So let us take a look. So we know that real number is either rational or irrational. So it is obvious that irrational number is a part of a real number. So basically, real number is a superset of rational and irrational number. So this is a true statement. Every point on the number line is of the form root m, where m is a natural number. So every point on a lambda number line is a real number which is rational or irrational number. So let us take a look. Root 2, root 3. So that's why it is a false statement, because number of other types like minus 5, minus 4, 1 by 2, minus 7 by 8, these numbers also lie on the number line, but which is not in the root m form. Every real number is an irrational number. Real numbers can be rational or irrational numbers. So that's why it is a false statement, because rational numbers are also real numbers. Now, next problem. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. So, this is a false statement. So, square root of all positive integers are not irrational. For example, 4, 9, 16, 25, etc. are positive integers, but their square roots are rational numbers, because we know that square root of 4 gives us 2, square root of 9 gives us 3, square root of 16 gives us 4, square root of 25 gives us 5. So all these are rational numbers. Now another problem. Write the following in decimal form and say what kind of decimal expansion each has. 36 by 100. So which can be represented in decimal form as 0.36, which is a terminating decimal. Now 1 by 11. So now let us solve this. Let us divide this. So 1 can be also written as 1.0000. Now take a look at the division process. So we can see that here is 0.09. This number is keeps on repeating. So that means that's why we can write it as 0.09 bar, which is basically non-terminating and recurring decimal. Now 4 1 by 8. So this is a mixed fraction. So let us first make it improper fraction, which comes 33 by 8. Now if we divide, we'll get it 4.125. So this is a terminating or recurring. Since it ends, there is whenever there is a non-terminating means it keeps on going. But here we can see that after certain point, like after 5, the remainder will be 0. So that means it is terminating. So that's why it is a terminating decimal. Now 2 by 11. So 2 can also be here, it should be written as 2, not 1. So there is a typing mistake. So 2 can also be written as 2.0000. Now take a look at the division process. So here we can see that after decimal point 18 is repeating. So that means 0.18 bar. So it is a non-terminating, repeating or recurring decimal. Now you know that 1 by 7 equal to 0.142857 bar, means 142857. This number is repeating. If you do the division, you will get this number which keeps on repeating. So now, can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, these numbers, without actually doing the long division? If so, then how? So now let us take a look how we are going to solve this. So decimals feature repetition here is 142,857. So now if we take a look, 2 by 7 is basically 2 into 1 by 7. So we can write it as 2 into 0.142857. So if we multiply, so we are getting 0.285714. Now do the same process with 3 by 7, that is 3 into 1 by 7. Do the multiplication of 0.142857 with 3. Now same process we will do with 4 by 7. Just multiply the repeating pattern with 4. Same goes for 5 by 7, that is 5 into 1 by 7. So basically whatever numbers we are getting, we are not dividing. Just by using 1 by 7, the number we got, we are just multiplying with the number. Similarly 6 by 7 is equal to 6 into 0.142857, and do the multiplication. So this way we got the answers. Now next question. Express the following in the form P by Q, where P and Q are integers and Q not equal to 0. It's 0.6 bar. Now let us take 0.6 bar as x. So 0.6 bar can also be written as 0.6666. This will continue. So that is x equal to 0.66 dot dot dot. So let us give it as equation number 1. Now after the decimal point, how many digits are repeating over here? If we take a look, that only one digit, that is 6, is repeating. Hence, we need to multiply both the sides by 10, which has only one 0. Because since only one digit is repeating, that's why we are multiplying it by 10, which has only one 0. So multiplying both sides by 10, we will get 10x equal to 6.66. Let us name it equation number 2. Now subtract 1 from 2. So we will get 10x minus x equal to 6.66 minus 0.66. So 6.66 dot 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 minus 0.66, because this is keep on going recurring. So 6.66 minus 0.66, if we subtract, we will get 6.00. So that's why 9x equal to 6.0. So x equal to 6 by 9, that is in the lowest form as 2 by 3. And this is in the P by Q form. Now let us take a look at another problem. 0.47 bar. Here, just top of 7, there is a bar symbol. So that means 7 is repeating over here. So let us consider x equal to 0.47 bar. So that means 0.477 dot dot dot. Now since in this case also only one digit 7 is repeating, so that's why we are going to multiply both sides by 10. So we'll get 10x equal to 4.777 dot dot dot, that is equation number 1. Now we need to multiply both the sides by 100 also. So now we will get 100x equal to 47.777. So this is going to be equation number 2. Now we need to subtract equation number 1 from 2. So we will get 100x minus 10x equal to 47.777 minus 4.777. Here, since there is one non-repeating number, that is 4, that's why we have to first, after decimal point, we have to make the number which are repeating. So that's why initially we have multiplied with 10 and then we just multiply it 10x by another 10, so which becomes 100. So now we got 90x equal to 43. So x equal to 43 by 90. So this is in the form of P by Q. So this is the final answer. Now 0.001 bar. So x, we have to consider that 0.001 bar. So 0.001 bar can also be written as 0.001001, like this. So this is equation number 1. Now here we need to check after the decimal point how many digits are repeating. So in this case 3 digits are repeating, that is 001. Hence we will multiply both the sides by 1000, which has 3 zeros. So after multiplying both sides by 1000, we will get 1000x equal to 1.001001, like this. This is equation number 2. Now subtract 1 from 2, we will get so 999x equal to 1, x equal to 1 by 99. So this is the final answer. Now express 0.999 dot 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 in the form of P by Q. Are you surprised by your answer? With it, a teacher and classmates discuss why the answer makes sense. So let us take a look. So let x equal to 0.999. So which can also be written as 0.9 bar. So this is equation number 1. So now after the decimal points, how many digits are repeating? So only one digit, that is 9. Hence we need to multiply both the side by 10, which has 1 0. So multiplying both sides by 10, we will get 10x equal to 9.999 dot dot dot. So let us give this as a equation number 2. Now subtract 1 from 2, we will get 10x minus x equal to 9.999 dot dot minus 0.999 dot dot. So that is 9x equal to 9. So which becomes x equal to 1. So what we got is 0.999 dot dot is basically equal to 1. So yes, at a glance we are surprised at our answer when you observe that 0.999 dot 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 goes on forever. So 1 and 0.999 dot dot dot, and hence they are equal. But the answer makes sense. So there is no gap because we know that 0.999 dot dot it keeps on going. It is never ending. is closest to 1. That's why the answer makes sense. Now, another problem. What can the maximum number of digits be in the repeating blocks of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. So let us take a look. We have to divide 1 by 17. So 17 is the divider and 1 is the dividend. So 1 can be written as 1.00. We can add as many number of zeros as we want. So now let us take a look at the step-by-step division. You should also do it in your copy. So I'm showing you the step-by-step division process. So it keeps on going. And what we observe that every time we are getting a different remainder. So that's why 1.1 by 17 equal to. Now here if you take a look that at the end we got 1. So that's why 1 by 17 is equal to 0.0582352941174647. So since we got 1, so the same process will continue again. So that means whatever number we will get, again we will go and get the same number because we got the final after this process we got 1, that is the dividend that we have started initially. So again we will get the same set of numbers. So that means here this whole number set is repeating. So that's why we have given the bar on top of the entire number. So the maximum number of digits in the quotient after decimal point, there is total 16 digits. So the maximum number of digits in the quotient while computing 1 by 17 are 16. Now question number 6. Look at several examples of rational numbers in the form of p by q where q is not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representation or expansions. So can you guess what property q must satisfy? Okay. So let us take a look at the problem first. So now the question is given where their p and q are the integers with no common factors other than 1 and having the terminating decimal representation. So that means the denominator of the given rational number has either 2 or 5 or both of them as the only prime factors. Because you know that terminating decimal representation means in the denominator it has to be in the form of 2 to the power m into 5 to the power m. So 2 to the power m into 5 to the power, and it should be, if the denominator is in that form, then we can say that it is a terminating decimal. So that means in this case the denominator is either 2 or 5 or it has both of them as the only prime factors. So like 1 by 8. So now if we divide 1 by 8, we know that 1 by 8 is, it can be represented as 1 by 2 into 2 into 2. That means only 2 is there. So which is in the form of 2 to the power m into, so 2 to the power 3 into 5 to the power 0. So now let us take a look. If we divide this number, what we will get. So we got 0.125. Now another, let us take another number, that is 1 by 25. So same, do the division. So we got 0.04. This is also terminating. Now so in these both of these cases, we found that 1 by 8 is, the denominator is a, they has only one factor of 2, and 1 by 25, it has only the factor as 5 in the denominator. Now 1 by 50. So let us do this division. So we got 0.02, and if we do the factorization of 50, we will get 2 into 5 into 5. So if the denominator of a rational number in standard form has no prime factors other than 2 or 5, then and only then it is represented as a decimal number. So that means what we observe, that if the denominator in the standard form, it has only the prime factors as 2 or 5, then only we can represent this in the terminating decimal form. Now question number 7, write 3 numbers whose decimal expansions are non-terminating, non-recurring. So for the numbers to have non-terminating, non-recurring decimal numbers, that means it should be a irrational number. So like 3 numbers whose decimal representations are non-terminating and non-recurring are the square root of non-perfect square numbers like root 2, root 3, root 5, etc. Or it can be a number which is non-terminating as well as non-recurring, like 0.101001001001 dot dot dot, like minus 1.232342 you can see that each numbers are not repeating over here. Now question number 8, find 3 different irrational numbers between the rational 5 by 7 and 9 by 11. So let us do the division of 5 by 7 first. So we got 0.7142 dot dot dot. This means it will keep on going. Now let us do 9 by 11 division. So which we got 0.81 dot dot dot, because this number is also repeating. So 5 by 7, what we got? So here, though for 5 by 7, we have not done the entire division. So if we divide it in your copy, we will get that after 714285, you will get the same number repeating. That is, you will again get the remainder as 5. So whenever we got the remainder as the same dividend, that means we will get the same number repeating. So we can clearly stop over there and we can say that this is a repeating number. So that's why 714285, these numbers are repeating and we have put the bar on top of it. And for 9 by 11, we got the remainder as 9. So that means the same 8.881 will be repeating. So we will put 0.81. So bar will be on top of 81. So thus the three different irrational numbers between 5 by 7 and 9 by 11. So we have to write any three irrational numbers between these two decimal numbers. So these two decimal means these two non-terminating recurring decimal numbers. So we can take any numbers, any three numbers which are basically non-terminating and non-repeating between these two numbers. So these are the numbers. You can take any numbers between these two numbers. Now question number 8. Classify the following numbers as rational or irrational. Root 23. Root 23 is an irrational number as 23 is not a perfect square. Root 225. Root 225 is equal to 15 into 15 square root, which gives us 15. So which is a rational number. So root 225 is a rational number. Now 0.3796. 0.3796 is a rational number because it is a terminating decimal. 7.478478 dot dot dot. So we can see that 478, this number is repeating. So 7.478 is non-terminating and repeating. That's why it is a rational number. Now next comes 1.1010010001 like this. So in this case, this is non-terminating and non-repeating. If you take a look at the zeros are keep on increasing. So there is no pattern. So that's why it is non-repeating. So that's why it is a irrational number. Now exercise 1.4, question number 1. Visualize 3.765 on the number line using successive magnification. So first we need to draw the number line. And we will plot the numbers. Now we know that 3.765 lies between 3 and 4. So we'll magnify this 3 and 4 and we are going to make 10 equal divisions between 3 and 4. Now we will write 3 as 3.0 and 4 as 4.0. And we will write the successive decimal numbers in between. Now we know that 3.765, it lies between 3.7 and 3.8. So we will magnify again this part and make the 10 equal divisions. And now we are going to write 3.7 as 3.70 and 3.8 as 3.80. And we will write the decimal numbers in between. Now again we know that 3.765, it lies between 3.76 and 3.77. So we'll again magnify that part and make 10 equal divisions. So now 3.76 we will write as 3.760 and 3.77 as 3.770, and we will write the in between decimal numbers. And now we got the 3.765 on the number line. Now question number 2. Visualize 4.26 on the number line up to 4 decimal places. So first we are going to draw the number line. And now, since we know that 4.26 lies between 4 and 5, so we will just take 4 and 5 and do the 10 equal division and draw the and plot the in between decimal numbers. And now 4.26, it lies between 4.2 and 4.3. So we'll magnify that part and make 10 equal divisions. And we will again draw the number line where we will write the 4.2 as 4.20 and 4.3 as 4.30, and we will write the successive decimal numbers in between. Now 4.26 lies between, we know that, 4.26 and 4.27. Since it has asked that we have to do it up to 4 decimal places, so again we will do the number line. We'll expand that 4.26 and 4.27 with 10 equal divisions. So now it becomes 4.260 and 4.270, and we'll write the in between numbers. Now 4.26 lies between 4.262 and 4.263. So again we are going to take 10 equal division and do the number line drawing. Now 4.2620 and 4.2630, we will write the in between decimal numbers. Now we got 4 decimal places in between numbers. So this should be actually 4.26 bar. Okay, so that's why we can say that 4.26 bar, since the bar is missing over here. So 4.26, that means it will continue 4.26, 26, 26 like this. So since they have asked for up to 4 decimal places, so that's why we can just do 4.2626. So in the question, that bar is missing. So we have to plot till 4.2626. That's it. Now let us see how we are going to represent 1 by 2, 3, root 2 on the number line. Like 1 by 2, root 3 and root 2. They should be root 3 and root 2 because 3 we know already how to represent in the number line. So first we will draw the number line. So if you take a look, here we are taking 2 centimeter as 1 unit. So each marking we have taken 2 centimeter as 1 unit so that the number line will be bigger. Otherwise, it will be more closer. The numbers, the divisions will be more closer and drawing will not be so good. So now we are marking this as 0, 1, 2, 3, 4. Now we will just mark, we'll divide this all the numbers by 2. And we got 1 by 2. Now 2 by 2, we know that it is 1. Similarly, 4 by 2 is 2 and 6 by 2 is 3. So in the same number line, we got 1 by 2 and 3. Now coming to the root 2. But root 2 is not seen on the number line. So till now, we can represent 1 by 2 and 3 easily on the number line. But root 2 we can't see on the number line. So now we are going to see how we are going to draw the root 2. So to plot irrational numbers on the number line, we have to use the Pythagoras theorem. So, what is Pythagoras theorem? Pythagoras theorem states that if there is a right angle triangle, then the base square plus height square or perpendicular square equal to hypotenuse square. So now if we take a look in this figure, so we have considered that OAB is a right angle triangle where OA is equal to 1 unit and AB equal to 1 unit. Now we need to find OB. So by Pythagoras theorem, OB square, that is hypotenuse square, equal to OA square, that is base square, plus AB square, that is perpendicular square. So OB square equal to 1 square plus 1 square, that is equal to 1 plus 1 equal to 2. So if we take the square root on both the side, we will get OB equal to root 2. So now we are going to apply this on the number line. So we already got root 2. Now we will take that as a radius and we will plot that on the number line. So now this becomes, whenever we plot it on the number line, that root 2, so that becomes our root 2. Now to plot root 5 on the number line. So to plot on the number line, we have to consider that hypotenuse equal to root 5. So height is 1 and we need to consider the base. So we need to find out what will be the base. So we will keep the height as 1, but we need to find the base value. So let us take a look at the Pythagoras theorem. What will be the base value? Hypotenuse square equal to base square plus height square. So hypotenuse we have considered as root 5. So root 5 square equal to base square plus height we have considered as 1. So 5 equal to base square plus 1. So that means base square equal to 5 minus 1. So base square equal to, that means 4. So base equal to 2. So now if we need to plot root 10 on the number line, so what we are going to do? To plot root 10 on the number line, we will consider that hypotenuse equal to root 10 and we will always consider the height as 1 and we have to find the base. So again take a look at the how to find the base. Hypotenuse square equal to base square plus height square. So base square equal to 10 minus 1, that is base square equal to 9. So base equal to 3. Now note, to plot an irrational number on the number line, consider that hypotenuse equal to irrational number and height equal to 1 unit. So then we will get the base by using the Pythagoras theorem. So any number line when you are plotting, we have to consider the irrational number as the hypotenuse. Now practice set 1.2. So now represent the number line, represent the number root 5 on the number line. So first we will draw the number line. And here in this case we will consider the scale, that is 1 unit as 3 centimeter. So that the drawing will be more neatly, there will be more gap and drawing will be more clear. And accordingly we will plot the numbers. Now root 5, that will be the hypotenuse. So base, if we find out, we will get base as 2. So we will plot that base on the number line first. Now to draw root 5, we have to draw the perpendicular at point number 2. So we will take the protractor and measure the 90-degree, and we will draw the perpendicular. Now let us take a compass and we'll measure 1 unit. You can take the measurement from 0 to 1 or 1 to 2, any measurement, or 2 to 3, because all are of 1 unit, and we will take the measurement and cut that in the perpendicular. Now let us name these as O, A and B. So O is the 0 point as O, 2 as A, and in the perpendicular where it cuts as B. Now join this O and B with the help of a scale. So now this is going to be the root 5. Now take the compass and calculate the distance of OB and draw the arc which cuts the number line. So here we are going to take the OB as the radius. So it cuts the number line at point D. So this OD is now root 5. So this is the number line drawing of root 5. Now property of geometric mean. This property is applicable only to right angle triangle. In triangle AEC, let us take a look that angle AEC is 90-degree. EB is perpendicular to hypotenuse AC. So we can say that EB square equal to AB into BC. So EB is the geometric mean of AB and BC. So what we got? EB square equal to AB into BC. So we have earlier considered that AB equal to 9.3 and BC equal to 1. So EB square equal to 9.3, then EB equal to square root of 9.3. So this EB square you can also calculate by doing the hypotenuse Pythagoras theorem. So this is the property of geometric mean. So that is, if in a triangle AEC, there is another triangle ABE and EBC, both are right angle triangle, then we can say that EB square equal to AB into BC. So where EB is the geometric mean of AB and BC. So now we are going to use that property to represent the decimal square root of number line representation. So represent root 9.3 on the number line. So you have to follow some steps. So first step is we are going to draw a segment AB of length 9.3 centimeter. So first we will draw the number line and we will plot 9.3. So now AB is 9.3. Next step is produce segment AB to point C such that BC equal to 1 centimeter. Now next step, draw perpendicular bisector of segment AC which intersect segment AC at point D. So we have to find. Now, if you calculate AB, we know that is 9.3 and BC is 1 centimeter. So AC is 10.3. 9.3 plus 1, that is 10.3. Now we have to draw a perpendicular bisector of AC. So we will take the compass and we will put the needle on point C and draw a arc on both sides. Similarly, with the same radius, put the needle on A and draw another arc on both the sides. And now we are going to join. That will be the perpendicular bisector. And it intersects at AC at D. Now draw a semicircle with center as D and AD or DC as the radius. So AD and DC, since it is a bisector, so AD and DC are same. So we can take anything as a radius and we will draw a semicircle. So we will calculate that and draw a semicircle. So which intersect at A and C. Now draw a perpendicular at point B. So this is the 90-degree angle. So this is the perpendicular line. Now what is the length of this EB? So this is root 9.3. Now how? So let us use the same property by joining the sides EA and EC and form triangle AEC. So this is what we explained earlier by using the property of geometric mean. So what is the measure of angle AEC? That is, angle is 90 degree, that is angle subtended by the semicircle. Now in triangle AEC, angle A is equal to 90 degree and the segment EB is perpendicular to the hypotenuse AC. So EB square equal to AB into ABC, that is equal to 9.3 into 1, because BC we have considered as 1 and AB as 9.3. So EB equal to square root of 9.3. Now square root of 9.3 is EB, but that is not on the number line. So we have to put it in the number line. So now using the compass, rotate BE so that it intersects the segment AC at point F. So now this, we already considered that BE. So now BE we have put it on the number line, which is BF. So this BF is the square root of 9.3. So BF is square root of 9.3 now. So that is the number line representation of any decimal number. Now lecture 5. Exercise 1.5. Question number 1. Now let us classify the following numbers as rational or irrational. So we know that rational number minus irrational number always gives you irrational number. So 2 minus root 5 is irrational number because the difference between a rational and an irrational is always an irrational number. Now question number 2. 3 plus root 23 minus root 23. So what we got is 3. So which is a rational number? Now next question. 2 root 7 by 7 root 7. So root 7 will cut in both numerator and denominator. So we got 2 by 7, which is in the p by q form, which is a rational number. So rational number, we already know that p by q means this is a ratio of two integers. Now 1 by root 2. So 1 by root 2 is irrational because the quotient of a rational and an irrational number. The numerator is rational, but denominator is irrational. That's why it is an irrational number. 2 pi. 2 pi is irrational because 2 is rational, but pi is irrational. So that's why pi is irrational, because if you can, pi basically is 22 by 7, which if you divide, that comes non-terminating, non-recurring. It will never end. And there is no pattern. So that's why it is non-terminating, non-recurring. That's why it is a pi is a irrational number. So 2 pi is irrational. Now question number 2. Simplify each of the following expressions. 3 plus root 3 and 2 plus root 2. So let us do step by step. So first we will multiply 3 with 2 plus root 2, and then root 3 with 2 plus root 2. Now we will multiply 3 with 2 and then 3 with root 2, and then root 3 with 2 and root 3 with root 2. That we got root 6. Now next problem. 3 plus root 3 and 3 minus root 3. So here we are going to use the identity a plus b into a minus b, that is a square minus b square. So we are going to replace this a by 3 and b by root 3. So here we will get 3 square and root 3 whole square, that is 9 minus 3, that is equal to 6. Now next question, root 5 plus root 2 whole square. So now this question we are going to use the identity a plus b whole square equal to a square plus 2ab plus b square. So here a is root 5 and b is root 2. So root 5 whole square plus 2 into root 5 into root 2 plus root 2 whole square. That gives us 5 plus 2 root 10, and root 2 whole square gives you 2. So that means 7 plus 2 root 10. That is the final answer. Next question. 5 minus root 2 and 5 plus root 2. So here also we are going to use the identity a plus b into a minus b equal to a square minus b square, and replace a by 5 and b by root 2. So root 5 whole square minus root 2 whole square, that is 5 minus 2 equal to 3. Now question number 3. Recall, pi is defined as the ratio of the circumference, say c, of a circle to its diameter, say d. That is pi equal to c by d. This seems to contradict the fact that pi is irrational. Earlier we have learned that the circumference equal to 2 pi r or pi d. So in turn we can say that pi equal to c by d. So but c is a number, and that's why it looks like that it is in the p by q form. So it seems contradict that pi is a irrational. So how we are going to solve this contradiction? So let us take a look. There is no contradiction as either C or D are irrational and hence pi is an irrational number. Why in this case uh, C or D? So C or D we are considering normally uh, we consider the rational where p by q where p is an integer and q is an integer. But since pi is related to a circle, so circle means it a diameter and circumference. So which we consider that it is a length, it is a measurement. So measurement can be a decimal also. It may be a decimal. So that's why if it is a decimal number, then it cannot be an integer. So that's why C and D can be a non-integer. So that's why we can say that. So basically, it is not a contradiction because C or D can be decimal, which can be a irrational number, right? So that's why it justifies that pi can be a irrational because if any, we know that if any of C by D is irrational, that will be a irrational number. So that's why pi is an irrational. So that justifies our point. Now, lecture number 6. Write the conjugate of the following surds and find the product of each pair. Now, the surds is root 3 minus root 2 and the conjugate is root 3 plus root 2. So, the product will be root 3 minus root 2 into root 3 plus root 2, which gives us root 3 whole square minus root 2 whole square equal to 3 minus 2 equal to 1. Similarly, root 5 plus 1, if the surd, then conjugate will be the opposite of it, root 5 minus 1. So now do the product and apply the identity. We got the product as 4. Now 4 root 3 plus root 27. So the conjugate will be 4 root 3 minus root 27. Just the opposite. We have to change the sign. If surd is a plus b, then conjugate will be a minus b. Or if surd is a minus b, then conjugate will be a plus b. So we got 21. If surd is root xy square minus square root of x square y, then conjugate will be xy square root plus root of x square y. Then do the multiplication. We got xy square minus x square y. Now question number 5. Rationalize the denominator. 4 by root 5. So root 5 here is irrational, so we have to rationalize it. So whenever we have a irrational number in the denominator, we have to multiply the same irrational number so that it becomes the rational number in the denominator. So here comes 4 root 5 by 5. Then question number 2, 1 by root 12. So first we have to simplify it. So root 12 is 4 into 2, that is 2 root 3. Now we are going to multiply root 3 in both numerator and denominator. So we got root 3 by 6. Now exercise 1.5. Question number 5. Rationalize the denominators of the following 1 by root 7. So we are going to multiply root 7 in both numerator and denominator. So we got root 7 by 7. Now next question. 1 by root 7 minus root 6. So here conjugate of root 7 minus root 6 is root 7 plus root 6. So we have to multiply that in both numerator and denominator. So now we are going to apply the identity a plus b into a minus b equal to a square minus b square in the denominator. So which becomes root 7 plus root 6 by 7 minus 6. So that means root 7 plus root 6. This is the rationalized form. Now next question, 1 by root 5 plus root 2. Same way, the conjugate of root 5 plus root 2 is root 5 minus root 2. We have to multiply this with both denominator and numerator. Now apply the identity in the denominator. So we got root 5 minus root 2 by 3. So in this way we have rationalized the denominator. Now next question, 1 by root 7 minus 2. So the conjugate of root 7 minus 2 is root 7 plus 2. So we are going to multiply this with both numerator and denominator. Now apply the identity is plus b whole into a minus b equal to a square minus b square. So we got root 7 plus 2 by 3. So this is the answer. Now if root 2 plus root 3 by 3 root 2 minus 2 root 3 equal to a minus b root 6, find the values of a and b. Okay. So first we need to find the conjugate of 3 root 2, that is find the conjugate of the denominator, that is 3 root 2 minus 2 root 3, that is 3 root 2 plus 2 root 3. And we have to multiply this in both numerator and denominator to rationalize. So now simplify this. Now apply the identity in the denominator. A plus b into a minus b equal to a square minus b square. So we got this. Now simplify this. Remove the bracket root 2 and multiply it with 3 root 2 plus 2 root 3, and similarly multiply root 3 into 3 root 2 plus 2 root 3. And if we simplify the denominator, we got this value. Now simplify the numerator and denominator. Now in the numerator we got 12 plus 5 root 6 by 6 equal to a minus b root 6. So now if we divide 6 in both, then that will 12 by 6 and 5 by 6 root 6. That is in the form of a minus b, that is 2 plus 5 by 6 root 6 equal to a minus b root 6. So a minus b root 6, we can also write that a plus minus b root 6. So now if we compare, a is equal to 2 and b equal to minus b equal to 5 by 6. Alternatively, we can say that b equal to minus 5 by 6. So these are the values of a and b. Now next question, show that 3 root 2 by 3 plus root 6 plus 6 by 2 root 3 plus root 6 minus 4 root 3 by root 2 plus root 6 equal to 0. So we have to consider the LHS first. And we have to multiply first. We need to rationalize the denominator. So we have to multiply the conjugate of it, that is 3 minus root 6 in both numerator and denominator to rationalize it. Then we will take the next set and we will multiply 2 root 3 minus root 6 in both numerator and denominator to rationalize it. Then we will consider the next set and multiply root 2 minus root 6 in both numerator and denominator to rationalize it. Now we are going to use the a square minus b square, that is a plus b into a minus b, in the denominator to simplify and then simplify the numerator. So now let us simplify the denominator. Keep on simplifying the numerator as well as the denominator part. Now since root 12 we can write it as 4 into 3, that's why we have done like this. Similarly root 18 we will write at 9 into 2. And now in this case 3 is common, so we have to take that. Next in this case 6 is common, we will take that one. And since there is minus and in the denominator also we got minus, so that will become plus. And we will take 4 as common. Now cut this. This is the final we got. And if you take a look, now we can cut these numbers and at the end we will get the 0, which is equal to the right hand side. So hence it is proved. So finally you can write hence proved. Next question, simplify this. So first it is in the form of a plus b whole square. So we will apply a square plus 2ab plus b square formula. And next one is a minus b whole square form. So we will apply that a square minus 2ab plus b square, this form. Now we are going to simplify it. Now to add, we need to equalize the denominator. So let us do the cross multiplication. So basically we are doing the LCM over here and do the cross multiplication. Now it is in the form of a plus b into a minus b, which is equal to a square minus b square. So we are going to apply that formula. So after the final simplification, we got 7 by 4. That is the final answer. Now lecture 7. Laws of exponents for real numbers. Product law. That we already know that a to the power m into a to the power m n equal to a to the power m plus n. These laws I think you have learned in earlier classes also. Just for a recap. Quotient law is a to the power m divided by a to the power n equal to a to the power m minus n. Double power law, that is a to the power m to the power n equal to a to the power m into n. Same power law, that is, power is same, base is different. A to the power m into b to the power m equal to a into b to the power m. Now let us do some exercise. Exercise 6.1.6. Question number 1. Find 64 to the power 1 by 2. So 64 can be represented at 8 square. 8 square into 1 by 2. So 2 into 1 by 2 becomes 1. So that is why it is 8. 32 to the power 1 by 5. 32 can be represented as 2 to the power 5 into 1 by 5. So that means 2 to the power 1 equal to 2. Now 125 to the power 1 by 3. 125 is 5 cube into 1 by 3. That is 5 to the power 1 equal to 5. Now question number 2. Find 9 to the power 3 by 2. So 9 can be represented as 3 to the power 2 into 3 by 2. So that is 3 to the power cube, that is 27. Now 32 to the power 2 by 5. 32 can be represented 2 to the power 5. So that becomes 2 to the power 2 equal to 4. Now next question. 16 to the power 3 by 4. So 16 means 2 to the power 4 into 3 to the 3 by 4. So which comes 2 to the power 3, that is equal to 8. Now next question. 125 to the power minus 1 by 3. 125 is 5 to the power cube into minus 1 by 3. That is 5 to the power minus 1. We can also write it in like 5 to the power minus 1 means 1 by 5. That is a to the power minus m equal to 1 by a to the power m. That law. Now question number 3. Simplify 2 to the power 2 by 3 into 2 to the power 1 by 5. So base here is same, power is different. So we will apply 2 to the power 2 by 3 plus 1 by 5 and we will do the LCM. So we got 2 to the power 13 by 15. 1 by 3 to the power 3 to the power 7. So 1 by 3 to the power 3 is 3 to the power minus 3. Now that is 3 to the power minus 21. Now next question, 11 to the power 1 by 2 by 11 to the power 1 by 4. So 11 to the power 1 by 2 into 11 to the power minus 1 by 4. That is a to the power m equal to a to the power minus m equal to 1 by a to the power m. We can apply that law. And now simplify this. So 11 to the power 1 by 4. Now next, 7 to the power 1 by 2 into 8 to the power 1 by 2. Here power is same, but base is different. So we'll apply 8 to the power m into b to the power n equal to ab to the power n, m, that formula. So 7 into 8 to the power 1 by 2, that is 56 to the power 1 by 2. Thank you. Please subscribe to my channel to get more updated content of different subjects on different topics. Bye.